Now let us use the midpoint theory. In the other example I've been using quite a bit so far in analytical geometry, with points A, B, C and D, and I'm going to look at my midpoint between AB and CD. My midpoint between AB is going to be given by, let's call that point P, and let's call the midpoint there point Q. My coordinates of P are going to be given by x2 plus x1, which is 2 plus minus 1 over 2, and my y value is going to be given by y2 plus y1, which is going to be 4 plus 7 over 2. That means that my coordinates of P, the midpoint of AB, are going to be given by 2 minus 1 is 1 over 2, which is just 1 over 2. 4 plus 7 is 11 over 2, which is either we can say 11 over 2, or we could turn that into 5.5. And those are my coordinates of P, the midpoint of AB. Now let us look at the coordinates of Q, the midpoint of CD. x2 plus x1 is going to be 3 plus minus 3 over 2, and my y value is going to be given by minus 5 plus minus 5 over 2. That's going to give me coordinates of Q. 3 plus minus 3 is 0 over 2, which is 0. That makes sense because Q lies exactly in between that, but it also lies on the y-axis, which means that the x value is 0. Minus 5 is equal to minus 10, divided by 2 is minus 5. And that also makes sense because it's on the line that is parallel to the x-axis. On the line y is equal to negative 5. That means that anywhere along this line, the y coordinate is going to be negative 5. And that brings us on to the distance formula. The distance formula is exactly that, the distance between 2 points. We are going to look at how to calculate the distance between 2 points on a Cartesian plane, and then we are going to look at a standard formula that we could possibly use. We are now going to look at how to derive the distance formula. Now with the distance formula, again I'm going to be using this graph that we've been using all along. I'm looking for the distance between A and B. The way I'm going to do that, well, let's look at this very carefully. Is this not a right-angled triangle? Yes? Now, according to the right-angled triangle, isn't AB the hypotenuse? And 2 and 3 are different sides. That means that AB squared is equal to 2 squared plus 3 squared. Yes? That distance is 2 and that distance is 3. But how did we get to that distance 2? We had to say 4 minus 2. Alternatively, to get to 2, we said y2 minus y1, and that's 2, so that's squared, right? And the same is going to be done for the x. Let's just erase this and write it down over here. We know that AB squared is equal to 2 squared, but instead of saying 2 squared, we're going to say 4 minus 2 squared. But instead of saying 4 minus 2, isn't 4 y value 2 and 2 y value 1? All of that squared, plus 3 squared. Same thing with 3, it's going to be given by x2 minus x1 squared. But we're not looking for ab squared, we're looking for ab on its own, so we square root both sides. That means that AB is equal to square root of y2 minus y1 squared plus x2 minus x1 squared. And that is our standard distance formula. If we apply it here, y2 minus y1 is going to give us 2 squared is 4 plus x2 minus x1 is 6 minus 3, which is 3 squared, which is 9. Boys and girls, do not turn this into square root. 4 plus square root 9 is not the same as 2 plus 3. 2 plus 3 is equal to 5. It's not what square root 4 plus 9 is. We can only split up the square root if we've got a multiplication. In this case we don't. So this is going to become square root of 13, and that's in its simplest surd form. If you do want to know what it is rounded off to 2 decimal places, it's equal to 3.61 units. But leaving it as root 13 is often the solution that is required. Now let us apply the distance formula again to this set of examples we've been looking at so far. I'm going to start by looking for the distance between AD. Now AD is going to be given by square root of y2 minus y1 squared, which is going to be minus 5 y2 minus y1, so it's minus 5 minus 4 squared, plus x2 minus x1, which is going to be 3 minus 2 squared. And that's going to equal square root minus 5 minus 4 is going to give me minus 9. Minus 9 squared is positive 81, plus 3 minus 2 is 1, squared is 1. That gives us an answer of square root 82. Square root of 82, I don't think it can be simplified further than that. No, it can't. We can leave it in that form, square root of 82. Alternatively, we could work it out to 2 decimal places, which is going to give us 9.055 or 9.06 units. But leaving it in that form is sufficient. And that's the distance from A to D. Now let us look at another distance. Let us look at the distance CB. CB is going to be given by square root of y2 minus y1, which is going to be minus 5 minus 7 squared, plus x2, which is minus 3, minus 1, x2 minus x1 squared, which is going to be given by square root of minus 5 minus 7 is minus 12, squared is positive 144, plus minus 3 minus minus 1 is going to give me positive 1, minus 3 plus 1 is equal to minus 2, minus 2 squared is equal to positive 4. So we're left with square root of 148. If you want to simplify that, 4 goes into 148,